Graphing lines. So let's consider a line 8x plus 14y equal 56. And so the first question is, well, how do we know this is even a line? They tell us it's a line, but how do we know? So I want you to look right here and right here. Notice we have two variables, x and y, and notice both of those are to the first power. So if you look right here, the exponent is 1, and the same thing for y. So let's think about the forms of lines that we know, the kind of typical ways we see them written. So one of the first ones we look at is something called, written in y equal mx plus b form, and it's called slope-intercept form. Then we have something called y minus y1 equals m times x minus x1. This is called point-slope form. And then we have two that look very similar, ax plus by equals c. And then sometimes you'll see it as ax plus by, instead of equals c, maybe c will be on the same side. Let's call it d plus d equals 0. The first one is standard form, and this one's general form. So look at each one of these. Y here is to the first power, just like we have. X is to the first power. If you look at the second one, point slope form, remember y1 and x1 are just numbers. We fill them in when we figure out what point we have. So y is to the first power, x is to the first power. Look at these two. Ax plus by equals c. X is to the first power, y is to the first power. Remember, a, b, and c are constants. Same thing here. X is to the first power, y is to the first power. So if you're looking at an equation where you have a combination of x's and y's, if you have x to the first power, y to the first power, you're talking about a line. Now, if there's a variable missing, like if that was just 8x equals 56, it's still a line because x is still to the first power. If the x part was missing, we had something like 14y equal 56. Obviously, we can reduce that, but y is still to the first power, so it's still a line. So the coefficients can really be any real number, but the exponents of x and y have to be 1 if you're talking about a line. Okay? So we're going to graph this line, and we're going to do it with two different processes. The first thing we're going to do is we're going to rewrite in slope-intercept form. Now look at it right now. 8x plus 14y equals 56. Do you see it's actually given in standard form? This is in standard form. So we want it in slope-intercept form, which means we're looking here. We want it to be like this. Y equal mx plus b. Okay, so if you look at this, I'm going to highlight it, slope-intercept form. If you look at it, you notice that y is all by itself. So what we're going to do is we're going to isolate the y term. Okay? So we have 8x plus 14y equals 56. We're going to get y all by itself, which means we're going to move the 8x. Well, it's positive 8x, so we're going to subtract it away to the other side of the equation. So when we subtract 8x over here, x's are gone, they cancel. And we end up with 14y on the left-hand side. On the right-hand side, now we have two pieces. We have 56 and we have negative 8x. You can write that as 56 minus 8x, or you can write it as negative 8x plus 56. Typically, we go in descending powers of the variables, so we put the x first and then the constant, but it's okay if you write it the other way. Now, if you look here, this y term again has a coefficient of positive 1. Well, the coefficient here is 14, so we want the coefficient of y to be positive 1. So we're going to divide by 14 here, but if we divide this term by 14, we have to divide every single term in this equation by 14. So the 14s are going to cancel. We end up with y. Over here we have negative 8x divided by 14. So let's consider this over here a little bit. We have negative 8 over 14. Well, we see 14 is not a multiple of 8, so we can't just simplify it that way. But let's look at factors of this. Both 8 and 14 are even, so probably they have a factor of 2. Let's try it. We see that 4 times 2 is 8, so negative 4 times 2 is negative 8. And 14 has a factor of 2. It would be 7 times 2. But if you wrote it like this, you see we have a 2 in the numerator and a 2 in the denominator. We can cancel those because we have a rule that says if you have a, b over b, those can reduce. And you're left with just a. Okay, so we can reduce this to get negative 4/7 x plus 4. because 56 divided by 14 is 4. So this right here is our slope-intercept form. Slope-intercept form is really useful because we can just look at it and give us the slope of the line. So remember, slope-intercept form was y equal mx plus b. So the m is the coefficient of x. So the coefficient of x here we see is negative 4 over 7. Okay? And we can read that just by looking at our equation. Really easy. That's why this form is really helpful. Y equals mx plus b. So the coefficient of x is our slope. It's that easy. Because this is in slope-intercept form, we could also find the y-intercept if we wanted to. B in slope-intercept form is the y-coordinate of the y-intercept. So the y-intercept here is not 4, b is 4, right? Here, b is 4. So the y-intercept is 0, 4. So let's graph the line using this slope-intercept form. So if we're going to graph the line was 8x plus 14y equal 56, and we want to do it in terms of slope-intercept form. We can start off with the point that we know, which is the y-intercept 0, 4. So we have it right here, 0, 4. And then we can use the slope to find other points on the line. So again, we're going to plot the y-intercept, and we're going to use the slope to find other points on the line. Now we only need 2 points to determine a line, but sometimes it's nice to find a few more. So let's look at this slope. Our slope is negative 4 over 7. Okay, we could actually write that 2 different ways. We could say that's negative 4 over a positive 7, and we could write that as 4 over a negative 7, because negative a over b is the same as negative a over b, or a over negative b. We can really put that minus in one of 3 places. Well, we know slope is rise over run. So if we group that negative with the 4, rise means up and down. The negative direction for rise is down. We could go down 4. And then run, we see we have positive 7. If you're running left to right on the x-axis. That's positive direction is right. So right 7. Okay, so we're going to start out at this point right here, 0, 4, and we're going to go down 4. 1, 2, 3, 4. Then we move right. 1, 2, 3, 4, 5, 6, 7. And we are right there. Okay, let's look at the other way of writing the slope. We could look here and say, well, instead of negative 4, we can write it as a positive 4. So rise is positive. So positive 4. That means we're going to rise. We're going to go up 4. Okay, and then the run now is negative 7. So if you're going to run, remember you're running left and right. You're running on the x-axis. So negative is given as left. So we can go up 4. 1, 2, 3, 4. And left 7. 1, 2, 3, 4, 5, 6, 7. Let me do it in purple. Right here. That is another point on this line. So let me connect these in a beautiful straight line using my straight edge. Okay, pretty good. So I can label this as y equals negative 4 over 7 times x plus 4, or 8x plus 14y equals 56. But I actually graphed it by starting with the y-intercept and using the slope to find other points. Let's consider the same line, but let's do it a little bit differently to find the graph. Okay, so we had 8x plus 14y equals 56. Let's start out by finding the intercept. So let's just back up a bit. Let's talk about intercepts. So in general, this is the x-axis, this is the y-axis. If I'm looking at a graph, just some graph like this, we can see that this point right here is where the graph intercepts the y-axis. We call that the y-intercept because the graph intercepts that axis or touches that axis. In this case, it crosses as well. That's the y-intercept. Look carefully at it. The y-intercept is where the graph, as we said, intercepts the y-axis. So it's right along the y-axis. I don't go to the left. I don't go to the right. I am exactly on the y-axis. So I have not moved left or right. That means the x-coordinate is 0. And usually we use b, like you see over here when we had mx plus b. Usually we use b for the y-coordinate. Okay, let's look at this one. This point right here is where that curve and the x-axis touch, right? Where the curve intercepts the x-axis. So this is called the x-intercept. Well, again, I'm right on the x-axis, intercepting the x-axis. I don't go above, I don't go below. I'm exactly on that axis. So the y value here is 0. So to find the y-intercept, we set x equal to 0. To find the x-intercept, you can see right here, we're going to set y equal to 0. So let's look at our equation again. 8x plus 14y equals 56. So if we want to find the x-intercept, and I'm being lazy, just call it x-int, x-intercept, we are going to set y equal to 0. Okay? So this y, we're going to write 0 instead. So 8x plus 14 times 0 equals 56. This is 8x plus 0 equals 56, or really just 8x equals 56. Divide by 8, because we want the coefficient of x to be 1. So x is 7. But be careful, we said that y was 0, right? We're talking about an intercept. We are talking about a point. Okay, so here is y is 0. We're talking about the x-intercept. X is 7, and don't forget this guy, y is 0. So we write this as a point 7, 0. Let's find the y-intercept. To find the y-intercept, we set up here, we're going to set x equal to 0. So in other words, like I did just a few minutes ago, right there, instead of that x, I'm going to write 0. So we have 8 times 0 plus 14y equals 56. So 0 plus 14y equals 56. So that's really just 14y equals 56. We want the coefficient of y to be 1. So we divide by the current coefficient, which is 14. So we end up with 1y equals 56 divided by 14. Use your calculator, that is 4. But again, we see y equals 4, and x is 0, because that's how we started it. The y-intercept is 0, 4. And notice it's in this form that we used up here. Okay, so now we're going to graph this line using the intercepts. Remember, we only need 2 points to graph a line. So let's graph this. So we're going to graph 7, 0. Remember, this is the x-coordinate, this is the y-coordinate. So we're going to go 7 along the x-axis. It's positive, so we go to the right. So 7, and the y value is 0, so it's right on that axis. So this point right here is 7, 0. Let's plot the y-intercept. Coordinates are 0, 4. So x, y, x is 0, which means I'm on this axis, right? I don't go to the right, I don't go to the left. And then the y value says go up 4. 1, 2, 3, 4. So 0, 4. And I can plot this with a straight line. Again, 2 points are the minimum I need to draw a line. 8x plus 14y equals 56. This is exactly the same line we drew a few minutes ago. Okay. This one has a few more points on it because we used the slope, but you get the same thing. The point was 0, 4 to begin with. We didn't label this point, but let's look at it. 1, 2, 3, 4, 5, 6, 7. Interesting. So the coordinate here is 7, 0, just like we got here. They're both, equally easy to graph depending on what you're given. If I am graphing something that's given to me in standard form and I just need the graph, I'm probably going to use the intercept method. Let me show you a little bit different way to do that. So if I have 8x plus 14y equals 56, and I'm trying to find intercepts, I know that if I want to find the y-intercept, like we did a few minutes ago, I set x equal to 0. So I just use my hand. I'm just going to use this marker, but use your hand and cover up the 8x. Because if you set x equal to 0, that piece is gone. It's 0, right? So then you're really solving 14x equals 56. So you get 0, 4 like we did a few minutes ago. So if we're finding the x-intercept, we cover up the y, because we're going to set y equal to 0. And you see it's gone, right? So then you're really solving 8x equals 56. Well, 7 times 8 is 56. So I can do this pretty quickly. But if I'm looking for the slope, I need the slope anyway. It's very easy to take this equation and solve for y.